Polynomials lesson number 5, modeling and solving problems with these functions. Everyone's favorite, problem solving. But this allows us to take it to the application. Where would we use some of this information? Let's look at this first graph. This graph represents the path of a ball kicked into the air. What is the maximum height of the ball? The maximum height is going to be the highest point that it can go to. So sitting right up, right in here, we're looking at, it's going to go 12 meters. How far had the ball traveled horizontally when it reached that height? We're now taking it down to here, 8, 10, so it looks like half in between about 9 seconds. 9 meters. Horizontal distance, 9 meters. What total horizontal distance did the ball travel? It went up, and then it came back down and hit the ground way over here. So that's 18 meters. Using graphing technology, a certain airline's regulations state that the sum of the length, width, and depth of a piece of carry-on luggage cannot exceed 100 centimeters. Several models of carrying on luggage have lengths of 10 centimeters greater than their depths. So the length is 10 centimeters greater than their depth. So I'm going to look L equal length, D is equal to depth. And as soon as you start using variables, you've got to say what they are. Write a polynomial function to represent the volume. So then we've got a height as well as there. So a length, width, and then depth. So we've got a W for width. We want to get all of this into one variable. So you could use X's or Y's. I've used L's, W's, and D's. So we've got our L equal to D. Okay, let's start here. Your volume is your length times your width times your, in this case, the depth. Our L is D plus 10. Our width, we don't know yet. We'll get to that in a second. And our depth, we said, is just D. So now we need to figure out what goes for the W. Well, W, we know that the whole thing altogether must not exceed 100. So the sum of them. So we're going to add up 100 has to equal the length plus the width plus the depth. So we need to figure out and solve for W here in the algebra. The length is 100 equals D plus 10 plus W plus D. Let's subtract all that over. So we've got 100 minus D minus 10 minus D. Or in other words, 90 minus 2D. That we can now bring into here. At this point, we have something that we can graph. We've got an equation, V equals, and we've got one variable, V, which is really your X. So we're going to punch that into our calculator. We're going to be punching really in Y1 equals D plus 10 times D times 90 minus 2D. If you wanted to, you could expand that. There's no real reason to expand it, though. Now, we want something that is the maximum possible volume. So that means when we graph it, we're looking for a local maximum. And we have to remember that our dimensions have to be positive. So we're really only looking in quadrant 1. If there's anything that happens in quadrant 2, 3, or 4, they're really extraneous information. We can't use them because we need positive dimensions. So punching that into our calculator, we need an x minimum. So we have to figure out our window settings first. Let's just go with 0 is a good one on x minimum. Your x max, let's look at 60. Y minimum, that's probably good to go with the 0 as well. And then Y max, I'll put it at 40,000 so we can see it all. The scale doesn't really matter what you pick for your scale. When you graph this, you're going to get something that looks like this. Now, if you graphed it seeing all 4 quadrants, the actual graph would have extended like that to be a cubic. But we really only care about the 3rd quadrant. Now we're looking for our maximum point here, which in this case would be at 28.58, comma 36209.92. So to get our answer, what is the dimensions to the nearest tenth of a centimeter? Your depth, it is telling you, is 28.6 meters, or sorry, centimeters. Then your length, which was d plus 10, is 28.6 plus 10 gives us 38.6 centimeters. And then our width. Our width we said was 90 minus 2d. Or you could go 100 minus the first 2 answers, which will give us 32.8 centimeters. There's our dimensions. And the maximum possible volume, I'll put V max, is equal to the 36,209.92 centimeters cubed, cubic centimeters, or 36,210 approximately. What assumptions did we make? Well, we have to make that one assumption that this is a rectangular prism, that there's no curved corners on this luggage, and that's not realistic because they are actually most of the time curved, but we have to make the assumption that it's rectangular with square corners. So now looking at it for yourself, thinking it further, what would happen if the length, the width, and the depth, if the sum of that was halved? So instead of having 100, the airline says, oh, no, now 50. Would the maximum volume also be halved now? That's something for you to try to work through and figure out yourself. Now, question number 1 here. So, a piece of cardboard 30 centimeters long and 25 centimeters wide. So let's just do a quick drawing of that. 30 centimeters long, 25 centimeters wide. We're taking out an x centimeters out of each corner. X by x, x by x, x by x, x by x. And then we're going to fold that together. So, cutting out that part and folding it up. At this point, right along here, this whole thing was 30 centimeters. Now, the inside has 2 x's taken off. So it's now 30 minus 2x on that inside. Same kind of thing. The outside here was 25, but again, 2 x's were taken off. So the inside here is now 25 minus 2x. That's the base. If we look at our length and our width, we've written those. The height, when we bring this together, is going to fold up with the x's. And if you look at the nice picture that's in your book there on page 59, that helps you to see that you're going to have a box that looks something like this. Where you've got 30 minus 2x on one side, 25 minus 2x on the other side, and x going up. So write a polynomial function to represent the volume of this box in terms of x. Well, volume is equal to length times width times height. So our length, we're saying, is 30 minus 2x. Our width, 25 minus 2x. Our height, x. Doesn't matter which order we write these in at all. So 30 minus 2x, 25 minus 2x, and an x. At this point, we're going to graph the function. Our y value is our volume. We can't have a negative volume. The x value, that's the height. That's the chunk that was taken out of each corner. That can't be negative. So again, we can't look at anything that's in negatives. So we're only looking at quadrant 1. We'll graph the function. When you punch that into our calculator, we're going to be getting, and we need a scale. So an x scale, x window. I'm going to start showing you how on the diploma exam they want the scale, or they're going to write the scale when they talk about it. X, the first thing on our list is the x minimum. Well, we just want 0. We don't want to go into the negatives. So minimum, maximum now. I'll give you a maximum of 15 and a scale of 1. Again, the last number doesn't really matter what you put there. Y. Again, 0 is our minimum. Our maximum, I'm going to give you it right now at 1600. You're going to have to be able to figure out which ones work best for yourself and for what you've got sitting on your screen. And that takes a bit of practice. When we punch it into our calculator, this as our y1 with this as your window, you're going to get a graph that starts looking something like that. What is the domain? Well, the domain of the function is from the lowest x value to the highest x value. So you're going to need to find that x-intercept. We know that this here, the lowest that it can be is 0. If I take out 0 of an x, we're going to have 0 as our volume. It's not going to be able to be made into a box. So we're going to have our domain is x where 0 is less than, it can't equal 0, x, which is then less than. Well, got to find out what this value is right there. So find your 0 of the function. Mind you, second, calculate, which is on the trace key. And then we're looking for the zeros. And you notice that that's going to become 12.5 here as a 0. That makes sense. You've only got 25 as a width. You can't take and cut out 12.5 from either side because then you're just folding it in half. You don't have a box anymore. You can't go further past half of the distance of the 25. So that number of 12.5 does make sense. And again, It can't equal the 12.5, or else we would just fold that piece of cardboard in half. To the nearest cubic centimeter, what is the maximum volume? Okay, where do we want maximum volume? We want to cut right here and find out what that maximum is. So to calculate your maximum, second, calculate, which is on the trace key, and we're going to number 4, which is the maximum. Left side, right side. You find your left bound, right bound, find your maximum in between. And it's going to come out to approximately 1,512 centimeters cubed as your maximum volume. We want to know what is the x value that went with that. When you did this maximum, it gave you an x comma a y. This is the y value. The x value at that point was 4.5. 4.5 centimeters. Now we've got our x value and the maximum volume. We need to then just figure out what the length and the width are by plugging them into the two other dimensions. So your height equal to 4.5. Your length was equal to the 30 minus 2 times 4.5, which gives us 21 centimeters for length, and your width was equal to the 25 minus the 2 times 4.5, which is 16 centimeters. So your dimensions are 4.5 by 21 by 16 to give you your maximum volume. If you multiplied those three numbers together, it better equal 1512. All right, working through this one. Clara and 3 friends were born on March 11th. Leslie is 5 years younger than Clara. So let's start making sentences from that. Leslie is 5 years younger than Clara. So Leslie is 5 years younger than Clara. That's the yellow C. Mike is 2 years younger than Clara. All right, let's try this one out. So Mike is, equals is 2 years younger than Clara. Thomas is 3 years older than Clara. So Thomas is 3 years older than Clara. Remember, whenever we put younger than, older than means put it on the end of the statement. Oops. There we go. And on March 11th, 2011, the product of their ages was 61,136, greater than the sum of their ages. Whoa. This is just crazy stuff. So, it's saying, let's just say the sum of their ages and their product of their ages. The sum is Clara plus Leslie plus Michael plus Thomas. The product is Clara times Leslie times Michael times Thomas. Let's fill these in with what we know. We know Clara, and some people really like to just use X's, so we could change C all the way along into an X if you want, or you could use a C. And I'm going to change it to an X just because most people tend to like the X instead of the C. So Clara's X plus Leslie, which is X minus 5, plus Michael, which is x minus 2, plus Thomas, which is x plus 3. When we combine all these, x plus x plus x plus x, that gives me 4x. Negative 5, negative 2, and a 3 gives me negative 4. 4x minus 4. There's my sum. The product of them, which is x times x minus 5 times x minus 2 times x plus 3. There's our product of those ones. Now it says the product of their ages was that much greater than the sum. So the product is this much greater than the sum. Let's fill in with what we know. The product was x times x minus 5 times x minus 2 times x plus 3. The sum was 4x minus 4 plus 61136. We could go ahead, you could expand that, collect all your like terms, equate to 0, and then refactor. That would be how to do it algebraically. We're going to use our graphing calculators for this. So the way to do this is take it all over to one side. So I'm going to bring all of this over to that side. This is method number 1. So I get x times x minus 5 times x minus 2 times x plus 3 minus 4x plus 4 minus 61136. Well, I want to combine the 4 and the 61136, so that equals 0. So I'm going to combine those two together and just use 61132. And that should have been a minus. Okay. I could just now graph y1 equals x times x minus 5 times x minus 2 times x plus 3 minus 4x minus 61132. Graph this. And I'm going to look for now, because x is an age, it's going to have to be positive, and I want to know where is this graph equal to 0. So find first positive x-intercept. So graph it, find your first positive x-intercept. All right, well, I'll walk you through this one. So on. All right, let's plug it into the y. So we've got x bracket x minus 5 bracket x minus 2 bracket x plus 3, and then minus 4x minus 61132. All right, well, let's look at what is the window set at. Okay, well, let's try to start there and let's enter and see if we find anything. Remember, I'm looking for the first positive x-intercept. I don't care about what the rest of the graph looks like. All that I really care about is whether or not anywhere along the x-intercept it crosses it. And it doesn't from 0 to 10. So let's we can go down to 0 for our x minimum. Let's go up, I don't know, 20. Let's see if that'll help. Graph it. Hey, there it is. Look at that. It crossed it right over here. So at that point, we know that it went and it crossed the axes. Let's find our 0 at that point. Second trace. Number 2 is our 0. And we need left bound. And we look at where it's sitting at. It's way below, and it's sitting at x of 10. And we're getting closer. I haven't seen it yet. Oops. Passed it. So you notice how it went from negatives. So it's in negatives right now. And if I hit one more, oh, it goes way into positives. So I know it's somewhere between 16.8 and 17.0. So let's go from there. Enter. Puts my cursor arrow up there and there. I'm looking in between those two and enter. And it tells me that the 0 is at 17. So that means that x equals 17. Or in this case, the meaning of 17 is Clara's age is 17. Then Leslie was x minus 5, so 17 minus 5, which is 12. And Mike gives us x minus 2, so that's 15. And Thomas was x plus 3, so 20 years old. There's all of the ages. Okay, so to finish off, answer those 2 questions for yourself. And if you want, you can start some of the questions.